Transformers on the Moon sounds like pure Hollywood, but here's the twist. This isn't just fantasy anymore. From Japan's toy-inspired lunar rover to NASA's shape-shifting robotic concepts, and now Tesla stepping in with AI-powered machines. Science fiction is edging dangerously close to science fact. And behind all this noise lies a serious question. Will the next generation explorers of the moon even be human at all? Or will it be Transformers? Not from Cybertron, but from Earth. The phrase, Transformers on the Moon, isn't just clickbait. It's rooted in two very real movements. Pop culture on one side, and cutting-edge robotics on the other. The idea of machines that fold, crawl, and reshape themselves for hostile environments has fascinated engineers for decades. Japan already tested the waters with Sora Q, a miniature rover that literally transforms to navigate the moon's uneven surface. NASA, meanwhile, has funded prototypes like Shapeshifter, drones and crawlers designed to reconfigure depending on terrain. And closer to home, Tesla has unveiled its Optimus humanoid robots, built with AI systems that, in theory, could adapt to environments humans cannot. So when people hear Transformers on the Moon, they're not entirely wrong. What's happening is the merging of three powerful threads: entertainment shaping imagination, robotics reshaping exploration, and private companies like Tesla turning wild concepts into working prototypes. It's no longer a question if Transformer robots will land on the moon, it's a question of when, and who will send them first. Do you think Transformer robots are better suited for lunar exploration than traditional rovers? Drop your answer. Robots or astronauts? So where does Tesla fit in all of this? In 2025, Musk doubled down on Optimus, the humanoid robot first teased as a factory worker, by suggesting its future lies far beyond Earth. According to Tesla's roadmap, Optimus isn't just for assembly lines. It could evolve into an autonomous explorer, adaptable enough to handle lunar construction, mining, and even maintenance of off-world habitats. The boldest hint came when Musk floated the idea of modular transforming robots capable of shifting between roles. Imagine a robot that can walk, crawl, and roll depending on the moon's rugged landscape. This isn't science fiction anymore. It's the kind of multi-form flexibility Tesla's AI and robotics divisions are actively prototyping. The pitch is simple. Why send separate rovers, crawlers, and bots when one reconfigurable system can do it all? Tesla believes that by combining its AI-driven neural nets with SpaceX's launch capacity, the moon could one day host teams of robotic transformers, building infrastructure before astronauts even arrive. What do you think? Should Tesla prioritize humanoid robots like Optimus or modular transformer-style machines for the moon? Let me know your take below. Before we picture armies of robotic transformers marching across the moon, we need to remember the lunar surface is brutal. Dust, finer than talcum powder but sharper than glass, clogs joints, scratches lenses, and wears down seals. Radiation from the sun bombards anything without thick shielding. And the temperature swings from 120 degrees Celsius in the day to minus 170 degrees Celsius at night. For machines, it's a mechanical nightmare. Traditional rovers, such as Apollo's lunar rover or modern designs, tend to be specialized: wheels for mobility and fixed arms for sampling. But Tesla's pitch is different. By creating modular, transforming robots, the idea is that these machines could adapt to multiple roles. One configuration for mobility, another for heavy lifting, another for delicate tool work, all in a single platform. More importantly, modularity could mean redundancy. If one part fails, the machine doesn't die. It simply reshapes around the problem. That adaptability could make the difference between mission success and mission failure, especially on long-term lunar bases. The moon doesn't forgive mistakes. So if Tesla's transformer-inspired robots can handle the dust, the dark, and the heat, they could become the workhorses of lunar colonization, laying solar arrays, mining regolith, and even assembling habitats before humans set foot on site. Do you think modular robots could really survive the moon's harsh conditions? Or are we overestimating Tesla's reach here? Tesla may be close to dropping the headline-grabbing phrase, Transformers on the Moon, but the race to master lunar robotics is already well underway. Around the world, space agencies and companies are developing their own versions of the machines that will one day build, mine, and even defend lunar outposts. NASA is preparing its Viper rover, a solar-powered machine designed to hunt for frozen water beneath the lunar surface. It's not flashy, but water, is the most valuable resource in space, and Viper's success could make or break long-term lunar settlements. Japan's space agency, JAXA, has been testing ultra-compact lunar robots that can reconfigure themselves into different shapes: rolling spheres, scouting crawlers, or linked-up towers. The idea isn't so different from Tesla's vision, though the scale is smaller. Meanwhile, the European Space Agency is experimenting with modular construction bots, machines that can snap together into larger systems, for simple carriers to complex assembly platforms. The competition is fierce, but each design tackles the same question: how do you build adaptable machines for a place as hostile as the moon? Tesla's entry changes the narrative because it leverages AI and robotics that are already being developed for Earth. If these humanoid-style bots can adapt their design for space, Tesla could shortcut years of specialized development. What do you think? Who do you think gets there first? Tesla's AI-powered transformers or traditional space agencies with decades of experience? Drop your prediction. Tesla, NASA, JAXA, or ESA? So let's cut through the hype. What exactly does Tesla have that could make this idea more than just a flashy headline? First on the list is Optimus. Tesla's humanoid robot is still in its early days, but it represents years of experience in building real-world robotics. Unlike traditional space rovers, Optimus is designed to adapt to human environments, walking on uneven surfaces, manipulating tools, and learning through AI training. Second, there is Tesla's AI. The same neural networks that allow Tesla cars to interpret chaotic city streets could, in theory, help robots interpret the unpredictable landscapes of the moon. Sand dunes, craters, shifting regolith. These are conditions where adaptability matters more than rigid pre-programming. And third, there is modularity. Engineers close to the project suggest that Optimus won't go to the moon in humanoid form alone. Instead, it could be re-engineered into units that transform, such as crawlers for scouting, lifters for hauling, or even construction rigs. That's where the Transformers comparison comes in. Of course, critics argued that this is far from proven. Tesla hasn't tested its robots in vacuum chambers, extreme radiation, or lunar gravity. For now, this is a bold reimagining of tools, not a finished solution. As I have said earlier, the phrase Transformers on the moon sounds like pure science fiction, and in many ways, it is. Hollywood gave us giant robots that fight battles across galaxies. Tesla isn't building that, at least not yet. Reality is slower, smaller, and far more fragile. A Tesla Optimus robot can barely walk across a stage without human supervision. Meanwhile, space robotics must survive extreme radiation, temperatures swinging from -170 degrees Celsius to +120 degrees Celsius, and the fine dust that has destroyed Apollo-era hardware. But here's where the comparison isn't entirely ridiculous. Modularity is already a key aspect of aerospace design. SpaceX's Starship, NASA's Artemis habitats, and even Japan's robotic systems rely on equipment that can change roles, cargo haulers that become habitats, and rovers that double as labs. Tesla's idea of reconfigurable robots borrows from that same philosophy. So while the imagery of Transformers stomping across the moon is fantasy, the principle behind it is not. The principle being that machines adapt their form for survival and efficiency. So what happens now? Tesla hasn't published a white paper on lunar transformers, but let's connect the dots. Their Optimus program is already in development here on Earth, focusing on repetitive, dangerous, and industrial tasks. The next logical step will be testing these robots in extreme environments, such as Antarctica, deserts, and eventually, space. SpaceX is building Starship to deliver cargo to the moon under NASA's Artemis program. If Tesla integrates, their robots could ride as payloads, testing lunar mobility in the late 2020s. By the 2030s, as lunar bases emerge, modular robotic systems could handle tasks from building habitats to maintaining solar farms. The bold claim is that Tesla aims to push beyond simple robotics into adaptive, modular machines that can swap tools, reconfigure their roles, and perhaps resemble the science fiction we grew up with. Realistically, Tesla is years, if not decades, away from anything close to the Transformers. But suppose the ambition aligns with SpaceX's transport systems and NASA's Artemis goals. In that case, it places them at the center of humanity's most ambitious experiment, turning the moon from a destination into a frontier. Would you trust a Tesla robot to build your first lunar base? Or should we leave that to space agencies? Drop your thoughts below. Now, let's step back because for all the excitement around Transformers on the moon, the idea comes with serious obstacles. Robots designed for Earth face challenges in space that are brutal and unforgiving. The moon's surface is coated in a fine, electrostatic dust that clings to everything and can shred moving parts. Temperatures fluctuate between blistering heat and extreme cold. Electronics can fail under radiation. Even mobility becomes questionable. Wheels, legs, and joints wear down far faster in lunar dust than in a Tesla factory. Then there's autonomy. While Tesla's AI is impressive, real-time communication with the moon has a 3-second delay. That means robots would need to operate independently, making critical decisions without human intervention. Today's Optimus isn't yet at that level. And let's not ignore the marketing angle. Some critics argue that Transformers buzz is more brand theater than engineering plan. Tesla thrives on ambitious promises, but its execution on earthbound products, such as the Cybertruck or full self-driving, has been marred by delays, setbacks, and controversy. And this brings us to another question. Do you think Tesla is genuinely prepared for lunar robotics? Or is this more of Musk's future showmanship to keep excitement high? I want to hear your take. So where does this leave us? Transformers on the moon may not mean shape-shifting robots battling in lunar craters, but it does mean something just as radical. The fusion of commercial robotics, space exploration, and visionary branding. Tesla, through its Optimus program, is hinting at a future where machines don't just assemble cars on Earth, they build habitats on other worlds. Is it realistic? That's debatable. But in aerospace, today's speculation often sets the stage for tomorrow's breakthroughs. Apollo, Starship, and Artemis were all once just bold ideas on paper. What matters is not whether Tesla has all the answers today, but whether its ambition sparks the race that brings answers tomorrow. So I'll leave you with this. Are robots like Tesla's Optimus the future pioneers of space? Or will they remain earthbound experiments? Drop your thoughts below. I'll be reading. And if you enjoyed this breakdown, don't miss what's next, because in our next video, we're exploring the most ambitious aerospace projects of 2025, from mega rockets to mega constellations, and the bold experiments reshaping our skies. Subscribe to stay informed.